popping up here in a minute. All right. How are you, Erin? It's good to see you.
Good to see you too, Daniel. Doing well. Happy Monday.
Yes, happy Monday. So for people tuning in right now and people who will watch a little bit later, I am Daniel Lossy, Principal and Chief Century Thinker, and welcome to Verdis Group's video series, where we meet to discuss the intersection of sustainability and climate action across our communities. Part of our role at Verdis Group is to connect people and organizations to each other and to ideas that accelerate climate action. And that is why I'm so excited to get to speak with the esteemed Dr. Erin Meyer, the Director of Conservation Programs and Partnerships at the Seattle Aquarium, because she is in the field and in the policy world doing great work around restoration, regeneration, and this blue carbon conversation. So from the ReShark initiative, repopulating zebra sharks in the waters of Indonesia, to conservation partnerships restoring kelp forests in the Salish Sea of Washington, Dr. Meyer is a charismatic scientist collaborating on collective big impact efforts to regenerate our blue planet. Welcome so much, Dr. Meyer.
Thank you, Daniel.
So I always love to ask kind of a personal question to get to know you and to set some context for why what we're talking about is so important. So Erin, I'm going to call you Erin for this conversation. Is that okay?
Absolutely.
Perfect. I would love to hear one story about your connection with the ocean.
Oh my goodness, only one. Maybe considering the topic and my background, maybe I'll think about and share a little bit about the first time that I jumped in the water into a kelp forest. So gosh, way back, many moons ago, when I did my first or final checkout dive, when I was getting my open water certification back when I was 12, we were off diving off of Catalina Island. And I will never forget when I jumped off that boat and descended down into that kelp forest off of Catalina, and just the magic of seeing this underwater forest and these fishes kind of sitting within the forest, like they were adorning these kelp forests, and these other fishes swimming in and out. And then there were marine mammals diving in and playing with our fins every now and again while we were diving in the kelp forest, and it was just magical.
So what does this magic do? Like, how does that inform the work you do on a daily basis?
Oh my gosh. Well, I wouldn't be doing what I was doing if I wasn't inspired by it or passionate about the ocean. And, I feel like I've known I wanted to be a marine biologist since I was like 4 years old. And getting certified when I was 12 and diving was just, one of many steps along the road that brought me to where I am today. And I think today, really, I do this work for my kids, for the next generation. So, hey, Daniel, so what inspired you to have this conversation today?
Oh my gosh. Well, so blue carbon is something that I knew nothing about until a couple years ago. And when Verdis started working with more aquariums, the Seattle Aquarium being one of them, I think it was actually you who brought the term blue carbon to my attention, and you were talking about the offsets that the aquarium was doing. And I'll be honest, I was at first scratching my head, like, what is she talking about, blue carbon? I don't know what blue carbon is. Is this a plant that's blue? And then you started to help me understand the concept of carbon sequestration and the ecosystems of our oceans, our marine waters, as a way to mitigate carbon and to draw down carbon. And so I was like, I started to get fascinated. And so as we've worked together, our team with your team, as we've been starting to work with more organizations and keep staying plugged into the climate change reports that the IPCC come with, the opportunities around blue carbon to more rapidly bend the curve of climate change is really inspiring. So I've been dabbling. I am no expert. I think nobody is probably an expert in blue carbon because it's relatively new and we're learning more every day, but there's so much potential with what we already know. So absolutely. I'm like, okay, I am not an expert in blue carbon, but I know some questions to ask. Who do I know who knows a lot more than me? And I thought of you and the work that you're doing, and with the Seattle Aquarium, and just in your science background and understanding marine ecosystems. So that's kind of how I came to it. And I can't wait to dive in and learn more. So
Nice.
actually, that's a great transition into, like, we keep saying blue carbon, but what is blue carbon? How would you define blue carbon, Erin?
Blue carbon in its most simplest form is the carbon that's captured and stored by the ocean and the ecosystems within it. So for example, just like trees and other plants on land, marine plants and algae, they pull CO2, so carbon dioxide, from the atmosphere, and they store it in their tissues. And just like green carbon storage on land, that blue carbon is then still stored locally for the duration of time that plant or that alga is alive. And then storage after that depends on what happens to all of that tissue, all of that dead plant and algal material, and whether or not it's buried in the sediment or whether it washes into the deeper ocean. And either way, if it's either buried or washes into the deep ocean, then that carbon, it continues to be sequestered for tens or hundreds or maybe even thousands of years.
And I think it's important, I know I didn't always know this, but the carbon cycle, right? There's always carbon being generated and consumed, kind of like the water cycle. I think of my third grader learning this in science class. Water evaporates and it gets groundwater, flows to the ocean, et cetera. Like, carbon is a cycle, but what's happened here is there's way too much carbon in the atmosphere, creating heating of our climate. The oceans are actually absorbing a lot more carbon dioxide, which is leading to acidification, which has its own problems. So the oceans are getting warmer and they're getting more acidic, but the oceans are doing an immense job right now, like absorbing a whole bunch of the carbon that we're excessively putting into the atmosphere, right?
Right. Yeah, they also passively absorb carbon. So not only, because there are marine plants and algae, they're actively pulling CO2 out of the atmosphere or actively pulling CO2 out of the water itself. The ocean itself is absorbing CO2. And I mean, it's also absorbing heat, but that's a whole other conversation.
And so the other thing that I would love to hear you talk about a little bit more is, like, that carbon cycle doesn't just stop with the plants. And yeah, some of the plants die and go into the sediment, some get washed into the deep ocean, but what else happens to plants in a marine ecosystem? Where else does that carbon cycle go to?
Oh, yeah. So they also get eaten. But before we get into that, so I realize I keep saying marine plants and I keep saying algae, and those might be terms people don't know either. So marine plants are things like mangroves that live in the intertidal area, salt marsh plants. So there are all these intertidal plants that live in those spaces. There are also marine grasses, so seagrasses. We have eelgrasses here in the Pacific Northwest, but there are eelgrasses and other kinds of seagrass all around the world. There are 12 families of seagrass that live all around the world. So there are many, many, many different kinds of marine plants. And then there are also many kinds of algae that also are pulling CO2 out of the atmosphere and out of the water column. So things like kelps and other kinds of algae that live in the ocean. So lots of different kinds of marine plants and algae. And then, of course, they're the base of the food chain, so they get eaten by other things.
Yeah, so I'm a man of the plains, living here in the Great Plains of the Midwest. And it blows my mind to think about, because I'm not an ocean guy, right? There are vast prairies of seagrass underneath the ocean. In my mind, as someone who's grown up in the middle of America, the middle of a continent, I always imagined the ocean was like a bunch of rocks where it's really deep and it's coral reefs. I only really imagined coral reefs, and then discovered kelp because I've done a little bit of exploring along the coast where there's kelp that grows. But so the kelp forests are like the terrestrial forests for me, the landlubber. And the eel grasses and other seagrasses are kind of like the vast prairies that we have on land. So that helps me think about how these ecosystems have some similarities. And I can relate to them a little bit more in that way. But prior to that, I was completely ignorant to all of these marine plants.
Yeah.
Cool.
The perfect comparison.
Thanks. So I'm going to show share a screen of a diagram that the IPCC, Intergovernmental Panel on Climate Change, just came out with this April. So it's only a month old. And for me, this was another reason why I got super interested in blue carbon, because of the potential impact it has. To simplify this graph, like, the longer the bar, the more carbon mitigation opportunities there are. So you have wind energy and solar being really large ones. And then the other thing that stood out to me is, what are these other three? Like, carbon sequestration in agriculture is this long bar. And these two got me really excited. This really long bar is the reduced conversion of forests and other ecosystems. So basically like protecting what we have, because we have a carbon cycle that worked for millennia before humans threw it off. And then this other relatively long bar is ecosystem restoration, afforestation, reforestation. So this is like, let's go back and help restore ecosystems that have been damaged or destroyed by human activity. The impact here is huge. And I'd like you to talk a little bit more about like, what's some of the science of this impact of blue carbon? Because I think about Arbor Day started in Nebraska. We work with people in the Arbor Day Foundation for carbon offsets to go plant trees, which is phenomenal. But there's some different ways of thinking about the blue carbon systems and the ecosystem protection and the ecosystem restoration. So tell me a little bit more about what types of blue carbon there are and how this interacts with this potential that the IPCC put out.
Yeah, oh my gosh, so much to say about this. So first, it's really so easy to plant a tree, right? Any human on the planet can go out and plant a tree or replant a prairie land. You can plant all sorts of plants really easy just by walking outside your door and finding some soil. Doing that in the ocean, it's a little more complicated. You're talking about ecosystems that live underwater. So some of these ecosystems require you to snorkel or dive if you're going to do restoration work. You can wait for seagrasses. They're intertidal. So you can wait for the tide to go out and do restoration. But they're influenced by tidal fluctuations, huge movements of sediment and water every single day with the tidal fluctuations and storms that are constantly hitting our coasts, particularly on the here in the Pacific Northwest. And so restoration in the ocean is complicated, and we're still learning how to do it, right? We're still learning how to do it efficiently and effectively. And so when I look at those two bars are both really important, but you see the protections bar is longer, in part because protecting what we have is more efficient and more effective, because restoration takes time. It takes generation times depending on the ecosystems you're restoring. So it takes time to restore things back to their full carbon sequestration potential. Their full biodiversity potential can take decades. And so if we can, invest time and energy and resources in protecting what we have, that's an investment in our future. That's an investment in biodiversity conservation, and that's climate action. So that's really important. On the restoration side of things, this is a really emerging area of research all around the world. So there's seagrass restoration happening here in the Pacific Northwest with kind of mixed results as we're learning the best methods for doing that and better ways to make it efficient and effective. There's eelgrass restoration and seagrass restoration happening in other parts of the world as well as mangrove restoration. So there is restoration happening in ocean ecosystems, and we do need to continue to put time and effort and resources behind that so that we can continue to improve our methodologies for doing that and make it more efficient, effective, and long lasting. And of course, partnering with local ecosystems or local communities as we're doing it. But you also asked about other kinds of blue carbon. So I just want to bring up that there's some less traditional, let's say, types of blue carbon that scientists have been discussing over the last few years. For example, we have these really big animals in the ocean called blue whales. Blue whales live a really long time. And a single blue whale, by the time it lives its full life cycle and it dies, it can be up to about 33 tons. It can store 33 tons of CO2 on average.
What? 33 tons. 33 tons.
One whale. And when that whale dies, it sinks into the deep ocean. So that carbon is sinking down into the deepest parts of the ocean. And that carbon is then sequestered for hundreds of years at least, because it's down in the deep oceans and moving through the cycles in the deeper oceans. So you compare that to like a tree. So one tree that we plant on land, of course, depending on the species that we're talking about, could sequester about 48 pounds or so of CO2 a year. 48 pounds versus 33 tons.
Wait. So I'm a math nerd. Let's just say it's 50 tons per year, 50 pounds per year.
Sure.
It would take 40 years for one tree to sequester 1 ton. 40 years to sequester 1 ton. And you said these whales can be as large as 33 tons.
Yeah.
Yeah, that's impressive.
So, creative ways to think about carbon sequestration too, as we're thinking about, restoring biodiversity and supporting the health and vitality of our oceans. That is an investment in carbon sequestration, among many, many other things.
Wow. One more reason to love blue whales. I had never thought about blue whales. And that's just one example, right? There's a ton of different whale species that do the same thing. Maybe not 33 tons, but maybe 25 tons, right?
Yeah. Blue whales are the biggest animal on the planet.
Well, and I believe that going back to the plants for a minute, I just recently read that the marine plants, the biomass of marine plants is larger. No, this was just, you're going to correct me. Was it algae? Phytoplankton. The biomass of phytoplankton is larger than all the terrestrial plants on this planet.
Well, there's that. And when we're thinking about it from a blue carbon perspective, the species in the ocean that we're talking about here, so mangroves and salt marshes and eelgrasses and even kelps to some extent, although the research is still out on that, can sequester 4 to 10, or some even estimate up to 50 times the carbon as terrestrial plants. So again, whole new area of research that we've really been digging into really in the last 10 years or so to understand the carbon sequestration potential of the ocean. But if we want to think about how we can accelerate climate action and carbon sequestration and kind of turning the tide back the other way on this progression toward 1.5 or even 2 degrees of warmth, it's investing in the ocean. That's where we need to be investing our time and efforts in protections and restoration.
Yeah, and the thing that hits me when you say that, Erin, is again, tree planting. This is what we know, Arbor Day, and it's great. Let's plant more forests. But I also know that forests have a tendency to catch on fire and burn with higher frequency than they used to because of climate change. So I don't foresee a kelp forest or a seagrass bed catching on fire and releasing that carbon back into the atmosphere through fire. So it also seems like not only is the potential that much more, it also is a safer long-term investment if we're really trying to do the numbers on carbon sequestration, because that carbon, though some of it does get cycled back into the atmosphere, the vast majority gets cycled down into the sediment or deep ocean. So just another thing to think about. And then you would know this stat. I think I have the number in my head, but I don't want to get it wrong. When I think about our planet, it's the majority is water, right? What percentage of our planet is water or ocean?
Oh goodness, of the coverage, it's over 70% of the coverage of the Earth is water, is the ocean. And of course, we're made up of 70% water as well. It's literally running through our brain, our brains, our bodies. It's running through all of us and connects all of us as well. The ocean, it's one big ocean that cycles all around our planet. We're all connected through its waters. And no matter where you are on the planet, taking action to help restore or protect the ocean is taking action for your local community and for the community on the other side of the planet as well.
And I learned from our own Omaha Henry Dorley Zoo and Aquarium that every other breath I take, the oxygen comes from the ocean and the plants of the ocean generating oxygen. So for all of my friends and clients and people that we work with or who are watching from not the coast, every other breath we take comes from the ocean. So that brought me another connection point to why it's so critical that even in the middle of the country, it's important to protect the ocean. So that leads me to kind of my last piece here. We always like to have, what is some practical action that viewers and listeners can take from this conversation about blue carbon? Because it sounds really big. It's really exciting, the potential that you shared, 2 to 10 to maybe 50 times the carbon mitigation drawdown potential as terrestrial programs. So what are a couple things that we can do as individuals or in our community?
Well, I always like to say it all starts with talking about this. So for those of you who are listening or listening now or listening later, you're learning about blue carbon. You're learning a little bit about why it matters to you. And if you can share that with your community, that's a really important place to start. The other thing that I always like to encourage people to do, and this every single person can do this, is use your voice. Now that you know a little bit about why blue carbon is so important for our planet, why kelp forests and eelgrass and mangroves and salt marshes are really important for our planet's future, talk about that with your elected officials. Tell them that no matter where you are, if you're in the center of the country or not, that you care about our coastal ecosystems, and that by protecting and restoring these ecosystems ensures that your family has a future. Use your voice. It's really powerful, especially coming from people in the middle of the country who aren't on the coast. Saying that to your elected officials can have a huge impact. And then for those of you who either as an individual you choose to invest in carbon offsets, or maybe your organization or the company you work for does, ask. If you offset, ask the company or the organization that you purchase your offsets through whether or not they have blue carbon options. Because the more we ask, the more we can drive the market to seek those options. There aren't very many blue carbon, certified blue carbon projects out on the carbon marketplace today. There are some for mangroves, there are some for like salt marsh and coastal scrub and things like that, but mostly in the tropical areas of the world. And we're just starting to see some movement to try and get some, here in the US, some of our eelgrass and other seagrass ecosystems on the market. I'm hopeful that that will happen in my lifetime, but hopefully in the next 5 to 10 years. I'm hoping to see some of those get up on the marketplace. But the more we ask, the more we can drive the market to go that way.
I love that. And you actually at the Seattle Aquarium drove your carbon offset provider to look at and find some blue carbon options for you to consider. So like, this is real. You can have an impact by talking to people, using your voice. I also wanted to just bring up, you talked about protection of existing ecosystems. And I know this might be, people might take this politically, but I want to share, like, this 30 by 30 initiative is not some political agenda. This is scientists saying that if we set aside 30% of our oceans and 30% of our planet to let nature just do what nature does best, it can create a regenerative ecosystem. It actually, the fishermen and women who were opposed to marine protected areas, basically a national park in the ocean, have actually discovered that their fishing catches go up substantially on the edges of them, because you've got this protected place where fish can do their thing and not be overfished. And then when they leave the boundaries, they can be fished, and there's plenty of space for everybody. So like, let's protect our planet and the beauty that nature already has, and the efficiency. Like, nature's the longest running R&D lab on the planet, super efficient at things like carbon sequestration and production of oxygen and cleaning up the pollution when given the chance to just do it. So like, I think about that. That's another way to use your voice, right? Tell your elected officials, like, it's good for us. It can even be privately owned land, but just like set it aside, and it's not going to be developed in a human way. Let nature do what nature does best. And let's get to 30%, not just in the US, but globally, and not just the waters along the coast of the US, but globally. Gosh, so much potential, Erin. And I'm so excited for the work you're doing at the Seattle Aquarium with blue carbon offsets. With you didn't talk about it, and I know we need to wrap things up, but I know the Seattle Aquarium is working with, I think it's the Port Authority, on some kelp forest restoration. Yes, or is it? Yes,
the Port of Seattle. Yeah.
Thank
so
you.
We just launched a partnership with the Port of Seattle to do some research on urban kelp forests. So right along our urban waterfront in Seattle, to understand where we're seeing kelp and why we're seeing it there and why we're not seeing it other places, so that we can move forward on kelp forest restoration, even in our urban environments along Seattle. It's so incredibly important to move forward on restorations and protections, no matter where you are. And urban environments allow us to connect our local communities more directly with our coastal ecosystems.
I love it. The Seattle Aquarium is doing such great work with regeneration. And so, like, this is another opportunity for organizations and businesses who are looking to offset. Find partners like the Seattle Aquarium who are doing the research, who are doing restoration and regeneration projects, because this is a team effort. It's going to take all of us to turn the tide and bend the curve of climate change so that we don't shoot past 1.5 degrees of warming. Erin, thank you so much for sharing a sliver of what you know. And I know you're always learning more, so perhaps we'll come back again and have another conversation. But for those of you watching, listening, or reading in the future, feel free to visit veritasgroup.com. We've got a blog. We have ongoing conversations with amazing people like Dr. Meyer to learn and connect you and people and organizations to ideas and projects that can accelerate climate action. That's what we're here for, to co-create a thriving and resilient world by accelerating climate action. So thanks everybody for watching. Hope you have a wonderful day and keep at it.